Hello and welcome to helpyourmath.com. In this video, we are going to go from the unit circle to the parent functions of sine and cosine functions, as well as some really important definitions for when we actually go to sine and cosine waves. This can be a kind of weird transition, so I'm hoping that this video will kind of help make sense of what we know from the unit circle and apply it to graphs in the coordinate plane of our sines and cosine functions. Usually we call those the sine wave or the cosine wave, because that's what it kind of looks like. It kind of looks like waves on an ocean. Okay, let's get started. We're going to first focus on our sine graph. So we're going to look at the parent function, y equals sine of x. And so when we're switching from the unit circle, which I have on the left, to the graph, which I show on the right, what we do is we basically, instead of going around the circle and around, is that turns into a curve, which we'll see. Now, when we graph our sine curve, we want to focus on three main points. The three main points are the point that's going to be exactly in the middle, the highest point, and the lowest point. And those points in the unit circle are always found on the axes. So we have the key points we have are 1, 0, 0, 1, negative 1, 0, and 0, negative 1. And the reason that those are important is because in a unit circle, what we know is that x squared plus y squared has to equal 1. And in order for x to be the largest possible value, y would have to be the smallest possible value. And when you're squaring something, what's the smallest possible value? That would be 0. So that means that the biggest coordinates that we can get are on those axes where one of the coordinates is 0, right? Anything else will be somewhere in between negative 1 and 1. So what we do is we're going to look at these key points, and we're focusing on sine. Remember what sine corresponds to in the unit circle? Sine corresponds to the y coordinate. So we look at our y coordinates, and that's going to help us set up our table of values for our sine curve. So we're going to start off where x is 0, and when x is 0, y is 0. Okay, so now that we have the first one, we're going to go to the next important point. The next important point is going to be up here at pi over 2. Generally, when we do the graph, it's almost always in radians. It can be in degrees, but usually it's radians. So here, this means we're plugging in pi over 2 into sine. And sine of pi over 2, it's the y coordinate, so it's 1. Okay, we're going to go to the next important point, which is going to be over here at pi. At pi, we're plugging in pi for x, so we have sine of pi, and sine of pi is that y coordinate 0. Going down to 3 pi over 2, I plug in 3 pi over 2, so that's my x value, 3 pi over 2, and I get this y, which is negative 1. Okay, now I go back here. So this was 0, but also after 3 pi over 2, it becomes 2 pi. It starts the circle over, or it ends the first circle. Whichever way you want to consider it, it kind of serves as both, right? It ends that first circle, it starts the second circle. So then we would have 2 pi. When we plug in 2 pi, we get that y coordinate of 0. If we were to go around the circle for a second time, so this would be 2 pi plus pi over 2, the next x value would be 5 pi over 2. And if I plug in 5 pi over 2, well, that's coterminal with pi over 2, so it's going to give me 1. Next, this would be 3 pi. And if I plug in 3 pi for x, then I get that y coordinate of 0. Now moving down, I add pi over 2, I get 7 pi over 2 down here. So the next x value I'm plugging in is 7 pi over 2, and I get that y coordinate negative 1. Going back up here, so 0, 2 pi, next would be 4 pi. If I plug in 4 pi for the sine, that's coterminal with 2 pi, it's coterminal with 0. We're going to end up with a y coordinate of 0. So now we're going to take this table and put it on a regular graph. So I see I want my x-axis to be units of pi over 2. So I'm going to skip every other one because it's going to get really squashed if I write them all in, but they're all in the table. So this is pi over 2. Here we have pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, and let's graph the y's. So here we have 1, down here we have negative 1. We start at 0, 0, the point 0, 0. We go to pi over 2, which is right here, up to 1. Pi 0, 3 pi over 2, negative 1. Then we go back to 0. So right there, I just graphed 5 points. Those 5 points make up one cycle of the sine curve, one cycle. we say that it's cyclic because you know what's going to happen? We're going to see that exact pattern repeat when we do the second cycle. So I start here at 2 pi 0. I go over to 5 pi over 2, 1. So see, I'm going up. I go back to 0. I go down to -1, back to 0. And this is going to keep happening, right? I could keep adding points to this, and it's going to happen over and over. When we connect the points, do not do sharp edges. These are sine curves. Curve means rounded, so we want this to be rounded as best we can. Hit each point. And this would be 2 periods of a sine curve. So that's taking it from the unit circle and kind of transposing it to a regular graph. Let's take a look at cosine this time. So when we have cosine, this is y equals cosine x. Remember that cosine in the unit circle corresponds to the x coordinates. So I know this can be a little bit weird that we're talking about 2 different x's here. We have cosine of x, that's our input, and then we have the x coordinates that corresponds to cosine in the unit circle. So we're going to start our unit circle at 0, just like we would start anything at 0, right? Usually we do. So here we have 0. This means we're going to do cosine of 0, and cosine of 0 will be the x coordinate. Cosine of 0 is 1. Going up here to pi over 2. Cosine of pi over 2, so next we're plugging in pi over 2 for x, would be the x coordinate 0. Going around to pi, if we take cosine of pi, that would be the x coordinate -1. Down here to 3 pi over 2. If we plug in 3 pi over 2, so that's cosine of 3 pi over 2, we would get the x coordinate 0. Back up to 0, which now is 2 pi. Cosine of 2 pi will be the same as cosine of 0 because they are coterminal, and that would end up being 1. So we've just completed 1 period or 1 cycle of our cosine graph. And what's going to happen if we go around the circle again? We're going to have this same pattern, 1, 0, -1, 1, 0, -1, 0, 1. 0, -1, 0, 1, 0, -1. So it's going to keep repeating over and over again, right? Because it's like going around the circle again and again and again. It's the same shape over and over and over again. So up here, if we were to add 2 pi to this, we would end up with 5 pi over 2. So if we were to plug in 5 pi over 2, that's coterminal to pi over 2. That's going to give us that x coordinate of 0. Going around over to 3 pi, if we plug in 3 pi, cosine of 3 pi will be -1. Going down here, this will now be 7 pi over 2. So we would have 7 pi over 2, and that would give us that x coordinate of 0. And back up to the beginning, which is now 4 pi. If we plug in 4 pi, cosine of 4 pi will be 1. So when we look at our parent function for our cosine graph, we start at the top. We start at 1. So we start at 0, 1. This is going to be pi over 2. This will be pi, right? I'm going to skip every other one just to keep this a little bit neat. 2 pi, 3 pi, 4 pi. And what happens next at pi over 2? We're down to 0. At pi, we go down to -1. We go back to 0 at 3 pi over 2. We go back up to 1. That completes the first period or the first cycle of cosine. Let's do it again. We go down to 0 at 5 pi over 2. Down to -1. Back to 0, and back to +1. And again, this is going to be a nice smooth curve. There's no sharp points on a curve. This is our parent function for cosine, so that's what it looks like. Now, these are functions. We've talked about functions before, and we know that functions do special things when we, add coefficients or add or subtract things. And we call those vertical and horizontal shifts, or we might have shrinks or stretches. But with sine and cosine graphs, they have different names. And so I want to review the vocabulary that we're going to see with sine and cosine graphs. So we might have a coefficient being multiplied to the function. Then we might have a coefficient being multiplied to x itself, something being subtracted from it on the inside of the function, and then something being added to it. And you might remember what these things mean. This thing means we're going to have a stretch or a shrink. This is going to be something really special that we usually don't see that with any other graph. We haven't really seen that before. So B is going to be something very unique. This is going to move the graph left or right. And what's this going to do? It's going to move the graph up or down. But again, we have special names for each of these. Let's talk about them. So one definition is the amplitude. The amplitude of the graph, this is either our sine or cosine graph, is represented by starting at the middle and going up to the tallest point, or you can go down to the shortest point, the lowest point. So you can either start, we're going to go back here, start in the middle. So this would be the middle of the graph, right? The middle of the graph is going to be where every other point hits. The middle of the graph, and the amplitude is going to go from the middle to the top, which would be 1, or the middle to the bottom, which would also be a distance of 1. Or if you go from the lowest point on the graph to the tallest point on the graph and divide that by 2. So that would be 2 over 2, which would give us 1. So our sine parent function, our cosine parent function, has an amplitude of 1. So that's what the amplitude is. Notice that it's not the entire bottom to top, it's half that distance. And the way we determine what the amplitude is we take the absolute value of A. So it's given in that equation, we take the absolute value. Now, because we're talking about a distance or a height, it has to be non-negative. In fact, it has to be positive. It can't be 0 because then we wouldn't have a graph at all. So we say it's the absolute value of A. Well, okay, but what happens if A is negative? To talk about that, we first need to introduce the idea of the midline. The midline of a sine or cosine graph is a horizontal line that is equidistant from the highest points and the lowest points on the graph. So where was that midline on our sine or cosine graph? That would be the horizontal line, y equals 0. How do we determine it for any sine or cosine graph? That's going to be this here. So this is kind of like the vertical shift in the graph. To figure out the midline, it would be y is equal to d. We like the midline. That gives us the basis of where the amplitude takes effect. So it starts in the middle, and then from there, the amplitude goes up or down. So the equation of the midline, I'm getting ahead of myself here, is y equals d. A sine function will start at the midline. So no matter what, that sine function starts at the midline. If A is positive, so here's where we're going to use the sine of A. If A is positive, then the sine graph will go up to the highest point on the graph, right? So we started at 0 on our sine graph, we went up to 1. Then we would go back to 0, then we would go down to -1. So when A is positive, we start by going up. If A is negative, then the sine graph would go down. And think about it, if sine is negative, then we're moving clockwise around the unit circle. Everything's going backwards. We would go down first. So for a negative A, we would start at the midline, we would go down the length of the amplitude. We would go back to the midline, go up, go back to the midline. So we're always making a stop at that midline. Every other point is the midline with sine or cosine. Either one, that's how it happens. So this would look like this. So if A is negative, we would go down first and then up. A cosine graph starts at the highest point if A is positive. So we saw that we started at 0, 1, which was the largest y coordinate we saw for any of the graph, any point on the cosine graph. A cosine graph starts at the lowest point if A is negative. But before you put that first point, you want to draw that midline. In either case, the cosine will then stop at the midline. So I suggest drawing the midline first, and then say, okay, well, if it's negative, if A is negative, I'm going to start down here. Then I go to the midline, then I go to the highest point, then I go back to the midline, then I go to the lowest point. So if A is negative, we start at the bottom, and it kind of looks like an omega when it's negative. If it's positive, it's the upside down of that, right? We start at the top, stop at the midline, go to the bottom, midline, top. Okay, so that's the idea of the amplitude and the midline. And this might be one of the few times that I mention midline. We're going to hear amplitude over and over again because it's super important, but I tend to neglect midline, and I shouldn't because it is also really important. So make sure you take note of the midline because I don't really talk about it too much again. The next important thing is the period, and this is going to use that b that we see within the sine function and cosine function. The period of a graph represents one complete cycle. So starting at 0 and going all the way around to 2 pi would be one period of the graph. Sometimes I do call it a cycle, so I kind of use those synonymously for better or worse. We can determine the period using the following formula, assuming that the domain is given in radians. So we're talking about radians, and keep in mind that to find the period, it's not just b. The period is equal to 2 pi divided by b. So if the period is just going to be 2 pi, then b is equal to 1, and we would just have a period that starts at 0 and goes to 2 pi, or has 2 pi from start to finish. If there's a change in the period, then we would say 2 pi divided by whatever is being multiplied to x within the function. So these have been an introduction going from the unit circle to the graphs and some key vocabulary that we're going to see as we look at more details of sine and cosine functions. Go ahead and watch the next videos so you can learn a little bit more about our sine and cosine functions. Thank you for stopping by.